review from last time and then move to some new stuff, if that's okay.
Okay.
To some new. So we talked at length about the power rule derivative, and if you've got pencil and paper, you definitely want to have, a
Yes.
notebook or something out. So
Yes.
if I give you a function like 5x to the third, the derivative is 15x squared, and it is that because you take this number, this 3, and you multiply it by that 5 and then subtract 1 here. So if you understand that, if that's all clear, let me give you your first example here. So let's just say that f of x equals 12x squared minus 4x plus 8. Go ahead and give me the derivative of this, please.
So it's 24 x minus of minus 4x.
So there's a power of 1 there. We talked about that last time. So it becomes x to the 0 power, but x to the 0 power is 1. That's why you don't even write anything here.
Okay. Plus 0.
Plus 0, and you don't have to write anything with that. Great. Okay. All right, and then give you another example here. Let's say we'll do g of x this time. G of x is 5 over x to the 4th plus 3x to the 5th minus 2. Okay. So do you remember what to do here with these problems?
Yes, so you bring the 4 up,
right?
Which is negative 5
Right.
over negative 4, 5x over negative 4.
Mm-hmm.
Over x or nothing? Oh.
Well, I mean, this is just rewriting it.
Oh, okay.
Okay. Now we're ready to take a derivative.
And plus,
okay. So you take this number
50
minus 4, multiply it by 5.
Okay, yeah, so it's negative 20 x over to the power of negative 5.
That's right.
Plus 15x to the power of 4. 0.
Yep.
Minus 0.
Okay. Let's look at another one here. Let's say y is equal to 2 over x minus 2x plus 2 plus x. Let's do the derivative of this. Okay. And again, probably it's good to rewrite.
Yeah. So y equals negative 2x.
Well, okay. It's 2x to the minus 1. Maybe you wrote that.
Minus 1. Okay. 2x minus 1.
And now we're ready to take a derivative. This is the calculus step, the derivative here.
Okay. So it's negative 2x over negative 2.
Mm-hmm.
Minus 2.
Okay.
Plus 0.
Okay.
Plus 0. What's this?
What number is in front here?
1.
1.
Plus 1. Okay.
So there's always a few little things here that could get you here. So these combine, that's minus 1. Okay. All right. So we're going to look at we'll move on to some new stuff here, and we're going to look at the derivatives of known functions. So the first one, let's say I tell you that y equals e to the x. The derivative is itself. It's the only function with this behavior. Okay.
I do not understand this.
Well, this is a rule, I guess. This is a derivative rule.
Okay.
Okay. So I'm gonna give you, so we're gonna go through, there's polynomials. Okay, we've talked a lot about those. There are exponentials. We're gonna talk about those. We've got logarithms. We've got trig functions. Okay, so there's nothing really to know here other than you have to know that like if I give you a function, the derivative is itself. Okay, so now we're going to talk about other exponentials. So let's say y equals a number to the power of x. Okay, and an example would be like y equals 2 to the x. The derivative is itself times the natural log of a, or the base. Okay, this is the derivative. So these are like derivative rules that you have to know. So over here on the right, we'll do an example. Y equals 2 to the x. So the derivative is itself, that's itself, like the same thing, times the natural log of 2, because 2 is the base.
So the question is,
It's the same question. All we're doing is what is the derivative? What is the derivative?
of 2x?
Yes, 2 to the x, 2 to the x.
2 to the
2
x.
to the x. So let's say I give you another example. Let's say I tell you y equals 4 to the x. What is the derivative? It's itself
You plug
times
in?
the natural log of 4. So yeah, this is the derivative. This prime, y prime, this is the derivative here.
And I'm supposed to calculate this, or is it
No,
just that?
no, this is it. This is it. Nope, just like this.
Just a plug-in?
This line is correct. This is, you're done.
Okay.
You're finished. There's nothing more to do.
Okay.
Okay, so let's look at another example here. Y equals e to the x. So the derivative is itself times the natural log of e. But what is the natural log of e? It's 1. So see how this is equal to 1. Yeah, this is a rule. This is a rule of exponentials. This is from pre-calculus or college algebra. Like this is something you're supposed to know going into it, but it's because this natural log of e is really log base e of e. And whenever you have the log base b of something that's b, it equals 1. So this is like a property of exponentials and logarithms.
Okay.
Okay. Now on the left here, this is important here that you see this. What does this simplify to? It simplifies to e to the x. So remember earlier I wrote one of the rules here.
Yeah.
Well, we now proved it. We showed why it works, because the natural log of the base e is 1. So that's why it works.
Yeah, and okay. And where's the proof that it works? Where's the
Well, it's the fact that the natural log of e is 1. So you can go right to this line right here. Y prime is e to the x.
Is it always 1?
Well, this part is, but the natural log of 4 isn't. That's why more generally, this is the rule. If you have a number to the power of x, the derivative is itself times the natural log of a.
What's it called? Natural log?
Natural logarithm.
natural logarithm.
Yeah, and usually log is said in short, like it's fairly common.
Okay. Okay.
Okay, so I have to do a bunch of explaining here before we can move on. But maybe I shouldn't here. Okay, so let me try to summarize the last few minutes. If a function equals e to the x, the derivative is e to the x. If I give you something like 6 to the x, the derivative, which is the calculus step, is 6 to the x times natural log of 6.
Yes.
This is what we said so far.
Yeah.
Okay. All right. Now we're going to look at logarithms. Okay. So let's say y equals natural log of x. The derivative is 1 over x.
Okay.
Okay. And this is a rule. This is again, this is just one of those like things that you got to remember.
Okay.
All right. Now, so these are natural logarithms. So the other type of logarithms is log base b. So this is y equals log base b of x. Okay. And the derivative is 1 over x times the natural log of b. Okay, so let me give you an example of that one. Okay, so an example would be, let's say it's y equals log base 3 of x. The derivative is 1 over x times the natural log of 3. That's this rule right here. So whatever the base is, 3, you have to put that in here in the bottom. Do you follow that?
So the base is put on the bottom.
Yeah. So what you have to be really comfortable with, okay, is there's 4 rules, but there's really only 2. Okay, because like this one always works on this one here, and then the one I just circled on the one on the right here, this one always works. The one on the left here is the shortcut. It's like if it's a specific log. Okay, so let me try and show you that here. Let's just say y is equal to log base e of x. The derivative is 1 over x times the natural log of e. But what is the natural log of e? It's 1. That's a property of logarithms. Okay, so this becomes 1 over x.
I just want to like look at it for a second.
Sure.
Could you go up a bit?
Well, let's just do some examples. Let's do some examples so you can see this again here. Okay, so we're gonna do them kind of side by side here. So let's say y is equal to 3 to the x. What is the derivative here? And
It's
it's
3 to the x, ln 3.
yes.
Okay.
Okay, now over here on the right, we're going to do the logarithm. Let's say it's log base 3 of x. The derivative is 1 over x natural log of 3. Let's do another one. Let's say I give you y equals 10 to the x. What is the derivative?
It's 10 to the x times ln times 3 times 10.
Yep. And let's say over here, it's y equals log base 10 of x. What is the derivative?
Derivative is 1 over 10. No, 1 over x
1 over x
log, no, what's it called?
ln of 10. Okay. All right.
Okay.
Okay. So let's do another one here. Let's say y equals 5 to the x. Okay. And then over here on the right, y equals log base 5 of x.
So that's gonna be 5 over x times natural log times 5.
Okay. And how about on the right here?
It's gonna be 1 over x ln times 5.
Okay. All right. So now let's go back and do the ones that we just talked about. Let's say it's e to the x. Okay. And then over here, it's y equals log base e of x.
So this is gonna be y equals
Y prime.
y prime equals
Y prime, yeah.
y prime equals e to the x ln times e.
Okay, but what is the natural log of e?
1.
Equals 1. Good. Okay, so
And
the derivative,
and what is the natural log of 5? Is it 5?
it's just this number. No, this is not known. This is just this is complete.
No, complete.
Like there's only certain ones that work out.
Okay.
Okay, how about on the right here?
This could be 1 over x
Okay,
ln e.
and what is ln e?
1.
Equals 1. Okay. All right, so the derivative is 1 over x.
Yes.
Okay, so now we need to review some logarithm properties. Okay. So let's say I tell you that the log of a times b equals the log of a plus the log of b.
Huh?
Okay. And the same thing applies here. Like if you say ln a times b, this is ln a plus ln b. This is from pre-calculus, college algebra, previous stuff. Okay.
Okay.
So let's say I tell you that y equals the natural log of 2x. This becomes the natural log of 2 plus the natural log of x. Do you see that? Like this is a, this is b. So they separate.
B. So that's the question? Or
Well,
that's
no,
the
we
answer?
have to take the derivative, but like you have to separate these first. So the natural log of 2 is a number. Do you agree with that?
Yes.
So what is the derivative of a number? So let's go look up. Let's go scroll up here. What was the derivative of 2?
0.
0, because it's a number.
Hmm.
So the same thing applies down here. The natural log of 2 is a number. So the derivative of natural log of 2 is 0. And natural log of x, the derivative of this is 1 over x. Okay, so that's a shortcut here. So that's an example. Let's have you try one. Y equals the natural log of 5x. So this breaks apart. It's the natural log of 5 plus the natural log of x.
Okay, so y equals
So the derivative,
5x. No, y equals 5.
0, the derivative of natural log of 5 is 0 because this is a number. And then the derivative of natural log of x is 1 over x.
0. Okay.
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 Are you following that?
Yes.
Okay. So let me give you another example here. Let's say y is equal to the natural log of 200x.
This is gonna be the 0. 100.
Well, it breaks apart, right? It's the natural log of 200 plus the natural log of x.
No, I'm supposed to break it apart.
Yes. Yeah, you have to.
Okay.
Okay, so the derivative here is 0 plus
0 plus 1 over x.
1 over x. Okay.
Is
So
it
now,
always 0? Is always 0 plus 1 over x?
well, it's always the derivative of a number is 0. That's what you have to remember. This is always a number.
Okay.
Okay, so like let's say I give you this, y equals pi plus pi squared plus 2 over pi plus natural log of pi. Is this a number?
Yes.
Okay, so what's the derivative of a number?
0.
Is this a number?
Yes.
So what's the derivative of a number?
0.
0. Is this a number?
Yes.
Is this a number? The
Okay.
derivative of a number is always 0.
Okay.
So from last week, we said, okay, if y equals c, y prime equals 0. And if y
Yes.
equals x to the n, y prime is n x to the n minus 1.
Yes. Okay.
Now this week, we're adding some things in, right? We're saying, okay, if I tell you y equals log, I'm sorry, yeah, if y equals log base b of x, y prime is 1 over x natural log of b. If y equals a to the x, y prime is a to the x times the natural log of a. So we've just added 2 more rules this week. That's all we're doing here.
Yes.
Okay, now there's more logarithm properties to remember. So the first property we did is log AB equals log A plus log B, okay? And then the related one is A times B equals log A minus log B. I'm sorry, plus. I'm sorry, ln. I'm writing the wrong one down here. Apologies. Natural log, okay? All right, so the next property we're going to learn is if I tell you the log base b of x to the n, this equals n times log base b of x. So basically you bring this down in front. You see that the exponent comes down in front. So an example of this, like let's say I tell you the log base 3 of 4 to the power of 2, that 2 comes out in front. It's 2 times log base 3 of 4. I give you another example. Let's say it's log base 5 x to the 8th. This 8 comes out in front. So it's 8 times log base 5 of x. You see that?
Yes.
Okay. So the reason that's important here is let's say I tell you y equals log base 6 x to the 5th. Okay, and I say I need the derivative. Well, the first thing you have to do is rewrite this. So
So
this is
it's
5 times log base 6 of x.
okay.
Now, last week we talked about the idea that this 5 just comes along. What is the derivative of this though? This logarithm part. It's 1 over
1 over x log over times 6.
6. Okay, and then sometimes you put this 5 up here, so it'd be 5 over x natural log 6.
Wait,
Good.
why is it log there and ln?
That's the
What's
rule. That's the rule.
Wait,
It's just
is it the same thing?
no,
ln and
no,
log?
but no, but no, but yes, effectively it is. I mean, it's essentially the same thing.
Oh, okay.
All right. Okay, so if you got this example down, let's try another one here. Let's say f of x equals log base 4 x to the 8th. Okay. I want you to determine the derivative. What is f prime of x?
So it's 8 log 4 of x.
Yeah, the original is 8 times log base 4 of x.
8 times log base 4 of x.
Yep.
Then it's gonna be 1 over x times ln times 4.
But this 8, what about this 8? See how it has to come along?
Oh, okay.
Okay, so the reason this 8 comes along, if I go back to these 4 rules that we've talked about, the other one is that if y equals a constant times a function of x, the derivative is the constant times the derivative of that function. So basically that number comes with. And that's what's going on here. So in these examples here, this 8 has to come with, this 5 has to come with.
Okay.
Hopefully you're starting to see there's a lot to remember here, and there's more
Yeah.
functions. This is just, small part of this. So let's do another example here. Let's say that y equals log base e x to the 9th.
This is gonna be
It's same thing. We're just
9
until
9
otherwise, yeah, we're doing derivatives. Derivatives is 9 log, yeah.
9 log e to the x. So you bring down the 9, you put the 9 here.
Sure.
Then 1 over x ln 9.
Yep. ln of e.
Oh, e. Okay.
What is the natural log of e?
That's 1.
Okay, so this becomes 9 over x.
Okay.
Okay, now in a related question, the natural log of x to the 9th, okay, what is the derivative of this? So the shortcut is you bring this 9 out in front, right? It's 9 times the natural log of x. Okay, and then
Okay.
it's 9 times 1 over x, because 9 natural log of x, the 9 always comes down.
Wait, so after 9 over x, then what happened?
It just becomes 9 over x.
So the answer is 9 over x?
Yes.
Then why did you continue after we got the answer?
Well, no, that's it.
Oh.
It's the same as the previous one. I'm trying to show you the relationship
Oh,
between. See, there's this relationship between ln and log, and this is
yeah.
from previous classes. So I'm trying to somehow establish it with you. And, I don't know how well that's going, but we're trying to cover a lot of math in
Okay.
a short amount of time here. Okay.
Okay.
All right. So, um, okay. All right. You still there, Hamad?
Yes. Yes.
Okay. All right. So, again, like we're doing just two types here. So let's say I tell you y equals 5 times 6 to the x. The derivative, this 5 always comes down.
Yeah.
What's the derivative of 6 to the x? 6 to the x times natural log of 6.
Why did you add the natural log times 6?
Well, if we go back to the rule that I'm using, okay, the rule says whatever the base is, you take the natural log of the base.
Okay.
This probably seems very confusing.
Yeah.
And it's because it's a mixture of calculus, and it's a mixture of stuff you're supposed to already know before calculus. Okay.
Oh,
So
yeah.
that's why we're running into problems here. So let's say it's y equals 4 times 3 to the x.
You bring down the 4.
That's right. 3 to the
And
x, natural log of 3.
okay.
Okay. Now let's go do some other ones. So let's say it's y equals 5 times log base 3 of x squared.
So you keep the 5, y
Well,
prime.
but before that though, you don't know how to take the derivative of this. You have to take this 2 and bring it.
Oh,
So it's 10 times log base 3 of x.
okay.
So y prime is 10, because you got to bring the 10 down. 1
Yeah.
over x, natural log of what number?
The 3.
Okay. So this is the correct answer, and you can simplify it to 10 over x natural log of 3. Okay. All right, so now let's try another one here. Let's say that y equals 3 natural log base 4 of x to the 5th, and I want the derivative. So give that one a try, please. How are you doing on that?
Oh, it was muted the whole time.
No
Um,
problem.
no, no, I got 15 over x ln times 4.
Good. Okay. Let's do one more here. So let's say f of x equals 8 log base e of x to the minus 3. And I want the derivative again.
24 log. What is next to the log?
Base
C?
e, base e, base e,
Oh.
sorry. Base e.
Okay, I got negative 24 over x ln times e, and it's e equals to 1.
Yeah, this equals 1, so you'd actually want to just write minus 24 over x.
Okay.
Okay. All right, so we're gonna move to just a slightly more difficult example here. Let's say y equals, well, actually, I have to give you the rule first. So we did not cover this rule. So let's say I give you log of a over b. This equals log a minus log b. So there's only 3 logarithm rules that I've shown you. This is one of the 3. The other ones, let me go ahead and show them to you. This is the product to sum rule up here. And then the next one was the exponent rule. Let's see if I can find that one here. Actually, let me just write them all down here.
I
for
still
you.
don't understand the AB thingy.
Well, it's meant to represent like 2 over x or x over 10. It's just a way to represent these things.
Yeah.
Okay. And then the last one is log base b x to the n equals n log base b of x. So these are the 3 rules you have to know. Again, this is like pre-calculus college algebra. You're supposed to know it. So it's like, well, if you don't know it, we spend more time on it, but this is the kind of stuff that will keep coming up in calculus, not in calculus 2, because they expect you to know it in your previous class. So it's this first one we're going to focus on. So let's say I give you y equals log base 3 2 over x. Well, this becomes log base 3 2 minus log base 3 x. And the derivative, what is the derivative of a number?
2.
What is the derivative of a number? That's from earlier.
0.
0. So this is 0 minus, what does this become?
1 over x ln 3.
Right. So your final answer is this part here.
Okay.
So let's do another one. Let's say f of x equals log base 2 x over 9. Go ahead and try this one for me, please.
Um, how do I simplify it? Like
So you break it apart as log base 2 of x minus log base 2 of 9. Do you follow that?
this 2 of 9. Okay.
Now, what is the derivative of the first one? The first one is, it's a
Wait,
function.
it always has to be minus?
That's the property up here. Whenever you're dividing, it becomes a minus.
Okay. So wait, I can't see. Go
Right,
down.
let me go down. There it is. So what's the derivative of this first thing here? Log base 2 of x.
It's 0.
Okay. Well, this is 0. This is not. This is 1 over x natural log of 2.
Oh, the other one's 0.
Well, that's because it was a number. See, all I did was flip the order, and you're trying to just pattern it. You're trying to say, oh, the first one's always 0. Well, no, it's it's not. It's a number here.
Because the x.
Yeah.
Okay.
And see, I'm trying really hard not to give you like exceptions or different ones, but the truth is I'm not really giving you the hard ones that you're going to see on a test. We're really covering very simple, easy ones for calculus. So just keep that in mind here. This is still a long shot here, but we're doing the best we can to do this. So
Yeah.
okay. So the derivative of the second one is 0.
Oh, okay. So the answer is 1 over x.
Natural log
ln.
of 2. Yep.
Okay.
Okay. Okay, so let's try another one. Let's say y equals log base 4, 5x to the 8th. And then we want the derivative.
So I got x8 log. I got 0.
Okay, maybe for the first one, but this you can expand the logarithm this way. Do you see that on the right here?
Oh, I forgot to add the log.
Yeah, and that's the properties here. That's the stuff that you got to be able to get down. So you can bring that 8 out in front, 8 log base 4 of x, and then you can take some derivatives if you want. Well, I'm asking you to, so I guess you have to.
Oh, X. No, 1. 8. 8 is here.
So here's your final answer here for this
Uh,
one.
Yes, I got
And-
that.
Great. Okay. All right. So let's do a review with some problems here. So these are so this includes the last lesson. So here's some problems that you should be able to do. And all of these are like find the derivatives. That's number one. Number two would be like y equals and then throw in one more here. Let's go y equals 5x to the fifth minus 9x all over x squared. Okay, so these are three problems that are from last week. So let's just go through these, make sure these are still clear. They're all the same. Find the derivative. What is the derivative?
Number 1.
Yeah, so go ahead and do number one. And when you get your answer, I will write down the correct answer, and then you can let me know if you have any questions on that.
So for number 1, it's 32x.
Good. Okay.
In.
Yep.
It's not over 15. No.
For which one? I'm sorry, x to the 15th. Yes, sorry. I thought I forgot to write that down.
Yeah, for number 2, it's 5 minus 2 over x.
This right here can be written as 2x to the minus 1. Do you see that? So this negative 1 comes down to the 2, so that becomes negative 2, but there's a negative there, so it becomes plus 2 x to the minus 2.
Oh. 2x. Well, how's it? Wait, why did you change the sign?
Well, I'm just going to rewrite it over here on the right here. And the derivative is 5. Now here it's minus, okay, that minus comes down.
Yeah.
It becomes, this negative 1 comes down, so it's negative 1 times the 2x to the minus 1, so that the minuses become a plus. Okay.
Okay. Yes. Okay.
Okay. And then it's plus 6x minus 0. All right, let me run through the last one here because we're running out of time here. So in the last one, you have to divide both of these by x squared before you take a derivative. So this becomes 5x cubed on the left, And the reason is if you have x to the n over x to the m, this becomes x to the n minus n. On the right, there's a 1 there, so this becomes minus 9x to the minus 1 because 1 minus 2 is -1 and 5 minus 2 is 3. That's how we got that number, and that's how we got that number. So now it's just a power rule derivative. You bring the 3 down, so it's 15, 3 times 5, x squared. -1 times -9 is +9, x to the minus 2.
Okay.
All right, so this is a good place for us to stop. We covered a lot of stuff today. Let me know when you want to schedule again, and we'll make it happen.
Could we schedule tomorrow?
Sure.
What time works best for you?
Let me get back to you by WhatsApp here. I need to look at my schedule again. I'll just message me in an hour and I'll give you an answer if that's okay.
And I'm having a physics test on Friday.
Okay, I will be available to help.
All right. Okay, I will tell you what time and everything.
Okay, sounds good. Thank you.
Thank
Bye now.
you.